So good morning, dear students, and welcome back. This side Govind, the new free chemistry mentor. Hope you people are doing good. I am also good. So here we are having a lecture number 2 for the electrochemistry. Till the last video we have discussed about the salt bridge. Now we are going to discuss about the function of salt bridge. So first function it is mentioned here. It maintains the electrical neutrality of half cells. Number 2, it completes the circuit by allowing flow of electron. Number 3, it maintains the liquid junction potential. Liquid junction potential. What is liquid junction potential, children? See, when you purchase a cell from the market, so 2 containers are not there. In one container only all the things happen. So this is the container. One side zinc rod is placed, one side this is zinc rod and this is copper rod, and here different solutions are filled. So what happened in that case? Positive charge, because zinc sulfate solution is having positive charge and this solution is having negative charge. So they maintain the liquid junction potential, and this is the junction. So they maintain the liquid junction potential. They becomes 0, plus minus 0. So that's why they maintain liquid junction potential. This is the work or function of salt bridge. Now I told you in the last video that in the salt bridge we have to use inert electrolyte. So what are the conditions for inert electrolyte that we will discuss? Condition for electrolyte. Number 1, condition for electrolyte means whatever electrolyte we have to fill in the salt bridge. So what are the conditions required? So condition number 1, inert. Whatever electrolyte we are using, it should be inert. Inert means what? Non-reactive. Whatever components of solution we are having, the electrolyte should not be react with components of solution. So here in the copper zinc cell we are using KCl. So what is the dissociation of KCl? KCl dissociate into K plus and Cl minus, right? So here you have to write ions do not react with any of the ions do not react with any of the ions of half cell. Whatever ions in the electrolyte we are having, These ions should not be react with ions present in half cells. Ions do not react with any of the ions of half cell. But here children, one problem happened. In the zinc container, Zn plus 2 charge is there and Cl minus ion is coming in that container. They will react. They will form ZnCl2. So our concept is failed because it is reacting, it is forming ZnCl2. But children, ZnCl2 is highly soluble. What it is? ZnCl2 is highly soluble. So when ZnCl2 form, immediate it dissociate into Zn plus 2 and 2Cl minus. That's why it is inert electrolyte. Hope it is clear. Point number 2, good ionic mobility. Good ionic mobility and equal mobility of cation and anions. Good ionic mobility, they have to be very slippery. That is why we are using gelatin or agar-agar powder along with inert electrolyte. And equal mobility, equal amount of cation and anions should be passed in each container. Otherwise, our process will not happen. The meaning is both half cells neutralize simultaneously. Both half cells should be neutralized simultaneously. So this is the condition for the electrolyte. Hope it is clear. Now the next part of the topic, cell representation. How will you represent the cell? So cell representation is very simple, children. Suppose you have to represent like this: M, metal, solid state, converted into left half cell we are talking, metal plus N, aqueous state, in second metal what? Copper. So M plus N, aqueous, and one line, then metal, solid state. So how to represent that zinc copper cell which we have discussed? So it is represented like zinc, solid state, one line, zinc plus 2, aqueous state, then double line, it's called salt bridge, then copper plus 2, aqueous state, one line, copper, solid state. That is the representation of your cell. You can check here, oxidation number 0, here plus 2. So it is oxidation half cell, here plus 2, here 0, reduction half cell. Oxidation number increases, so oxidation number decreases, reduction. So first is oxidation half cell and this is reduction half cell. There will be one problem in molar form. How to represent? when molarity is given, see Zn solid, so solid state no molarity, plus 2, here you have to represent molarity, suppose 1 molar, then Cu2 plus molarity 1 molar copper solid, like that you have to represent. In aqueous solution you have to write molarity, that's it. So cell reaction, now we will discuss the cell reaction. What is cell reaction? Cell reaction, so first reaction, zinc converted into zinc plus 2 electron, it is your oxidation half cell, then copper plus 2, it is accepting 2 electron converted into copper, reduction half cell. In the net cell reaction children, electrons should be cancelled, that you have to remember. So what is the net cell reaction? Zn plus Cu plus 2, Zn plus 2 Cu. You can write one note. In net cell reaction, electrons should be cancelled. In net cell reaction, electrons should be cancelled. So this is your net cell reaction. Okay, this is solid state, aqueous, solid state. So one question is given, what is the net cell reaction? It is given nickel plus 2 salt bridge Ag plus Ag. What is net cell reaction? So check it, write the equation. Nickel solid state to nickel plus 2, then silver plus accepting 1 electron converted into Ag solid, it's aqueous state, it is also aqueous state. What I said, electrons should be cancelled, so here 1 electron, here 2 electron, so this equation is multiplied by 2. Now electron cancel, so it will be nickel solid plus 2Ag plus aqueous, then nickel plus 2 aqueous plus 2Ag solid. That is your net cell reaction. I hope it is clear. So you have to cancel electron anyhow. That is the representation of this cell. Now we will discuss the electrode potential. What is electrode potential, children? In the case of electrode potential, Suppose this is a container, and in this container one metallic rod is placed, metal, and in the container electrolyte is filled. What is filled? Electrolyte. So suppose metal tendency is to oxidize, that the C of metal is oxidized. So what metal will do? Metal will do oxidation. Metal will release their ions, n number of ions and n electron, because metal tendency to get oxidized. So in the solution m plus n metal ions are coming. Yes or no? Because we assume that metal tendency to get oxidized. So what happened? Metal ions coming in the solution, m plus n, m plus n. So here this is your oxidation. In that case, what is the definition? The potential difference between the electrode, between the electrodes, which is your metal, and its ions in electrolyte is electrode potential. What I said, listen it very carefully. What is electrode potential? The potential difference between electrode means metal, and its ions in electrolyte under the equilibrium condition, under equilibrium, and its ion in electrolyte is electrode potential. Difference between ions and, what I said, potential difference between electrode and its ion is your electrode potential under equilibrium. So how can you represent now? Metal and electron, this should be happened because under the equilibrium. So in this condition, this electrode potential is called, because here oxidation happened, so this potential is called, what it's called? It's called oxidation potential. Oxidation potential. So just like oxidation potential, similarly reduction potential is there. Similarly reduction potential also there when the metal tendency is what? Reduce. If the metal tendency reduced, then it will be reduction potential. How? This is the container, metallic rod, this time here negative electron, so here positive charge on the rod, positive charge on the rod, then negative charge surrounding, m plus going to the rod, and here this is filled with electrolyte. So what happened? Metal accept an electron converted into metal. So it's called reduction potential. So two kinds of potentials are there: oxidation potential and reduction potential. If metal tendency to get oxidized, then oxidation potential; metal tendency to get reduced, then reduction potential. So these are the things of electrode potential. Hope it is clear to you. Now